Hi. We'd like to present a new routing daemon which we came up with last year. How does this work? The big green button doesn't do anything? Nope. This is the laser, and here nothing happens. Okay, so what is it? It's a new routing daemon which is written in Go. It is attempted to be as a library, or to be usable as a library as well. It's on GitHub, so you can use it. You can implement nice things or fix bugs, which hopefully are there. The thing started by Takt, Oliver Herms, who wrote tflow2 initially, a flow collector, and needed something to annotate the flow information with. So he started to implement tBGP a while ago. And we thought about, hey, let's do this for real, implement a real BGP speaker and more protocols in it. So BIOS stands for BGP, ISIS, and OSPF. That's our goal. So we created the biorouting project last year. Today we have 9 contributors. 2 of those are here. And I think we had 790 commits as of yesterday. It's in use at Exaring. Annika will tell more about that later. And by Mauve mail order software, where one of the other contributors is using it as a route injector. Why did we do this? There are a lot of implementations. There's BERT, there's Quagga, now known as free-range routing. There is GoBGP, etc. But most of them are single-threaded, so there are scalability issues. I see some people from DKIX here, which hack around BERT on a funny way there. There are other issues. BERT has a socket interface, but if you query it fast, it will explode. So we thought about, let's write our own.
Yeah, so we love BERT and we use it a lot, but a monoculture is never a good thing. So we thought, yeah, let's write another routing daemon. Yeah, we want to rely heavy on multi-core support. Our primary platform is Linux. That's why OpenBGP is also not a solution for us. So yeah, write our own. And most projects are written in C. And yeah, we thought, why not do it in Golang? Yeah, the main concepts of biorouting are, it's open source, it's on Apache 2.0. We focus on performance and memory efficiency, so we don't want to fill lots of gigabits of RAM just to hold the full table. We want to integrate as a library, so you can use it just in your own product or on your own SDN controller or whatever you want to do. We also want to have a full routing daemon, so you can just run it as a routing daemon like BERT or something. Then we want fast type-safe binary API, so gRPC is our API where you can communicate with it. And we have native Prometheus integration, so you get all the metrics out of it.
Okay, people start loving it. What we can do, BGP was the first thing we implemented as of the nature of the project. We can do add path. We support communities. We started supporting with large communities, then that legacy community stuff. We support 32-bit ASNs. We support multi-protocol support for v4 and v6 unicast. We have route reflection, route servers, filtering. We can do BMP receiver, and there is some ground support for FIP with Linux kernel and netlink. Currently, that's something, there is work be done. There are some open pull requests. So that's present. You can use this today.
Yeah, we at Exaring use it as a route injector to do some traffic engineering, for example, to reach some customers better or whatever. We have our own SDN controller, which communicates with biorouting over REST at the moment. The REST API is generated out of the gRPC API automatically. We run it on Kubernetes. It's stateless at the moment, so we run 3 instances or more, and those are completely stateless. So if one instance goes down, all routes are withdrawn and imported again from the SDN controller. Yeah.
What did we learn by doing this? A lot. RFCs are interesting read. The BGP RFC, I think 2071 or 4071, I'm not sure out of my head, is a lot of paper. a lot of interesting stuff, but sometimes it's confusing. So there is room for interpretation, which explains some things where vendors had to choose, and today I understand some choices. You have some software engineering problems like observer pattern internally. It's Go, so it's heavily multi-threaded. We use routines internally, so if there is an update, it is pushed into all tables, to all neighbors, etc. Test coverage is good, but it won't help you in all cases. You can't make up all tests, so fast testing is an interesting thing. Finding deadlocks is fun. Even if you have tests, the test library in Go has some problems. So while on the hackathon last year in Dublin, the RIPE hackathon, we had some fun finding the diffs between the test and reality. And well, if you use some terms like send and receive in configuration or everything, you have to explain where you stand. So when writing something like that, you learn a lot and you develop some understanding for vendors, which I didn't expect myself to say.
Yeah, so as we already implemented the B of bio, we now have to do the ISIS and OSPF part. And then there's also flow spec planned, and we want to have a CLI tool for bio routing, just like BirdC, so you can see all the routes and everything just from the CLI. And we are lacking configuration file support at the moment, which is, yeah, we should add this. I need this too for another project. Yeah, the source code is on GitHub. You can just contribute. Yeah. So thank you very much. Any questions?
Job Snyders, NTT. Good work. One comment with regards to ambiguous RFC texts. In the IETF, there's a working group called IDR, and that would be the perfect place if you have questions about RFCs. There are many people there that can provide you with historical context or share what choices they made and why they made them, and that may inspire you. So please subscribe to that mailing list, and if you have questions, that would be the set of experts that can help you.
Cool.
Cool, thank you.
Thank you.
Yeah.
I could just shout. The question is, in terms of the multi-thread support, did you do any tests in terms of, going from 1 core to 2 cores to 4 cores? How much of that actually comes through in the implementation? And maybe part of it is the Go support for it?
So do you mean performance testing with different cores? No, we did not yet. We have some offers from, I think, the FRR people who offered us to use their test suite. I guess we will go back to this when we are some steps more of the way. But correct me if I'm wrong, I think reading in 700,000 routes is 80 seconds or something like that?
Something.
On a 1-core VM.
Hello guys, it's good. It's very interesting for me to hear this project, and actually I'm from a network vendor, okay, from Huawei, and it's very good, but there's a different business case happened from my mind, okay. The first is for the small nodes, okay, for all the small nodes case, I think currently what you are showing makes sense. But my question is, do you consider write the code with a microkernel architecture so that your software can go through a cluster manner, so you can spread your calculation path in a distributed manner, so you can build a cluster, then you put some different calculation process to get a very good performance and a very good reliability in your system. So it's very clear from my expression. So for example, so today I believe all your code can running over a single server, right? So what I ask is, you can imagine you have maybe 4 or 8 servers. Then you build this 4 and 8 servers as a cluster. So you can split your process, like your BGP. If, for example, in your BGP you have many sub-process. You can spread all your sub-process cross over different machines, different servers. So you can get a very good high performance convergence calculation and real-time actions. So have you any plan, or you already built this architecture?
No, we don't use it yet, but as I said, we already run it in Kubernetes, somehow distributed, but not synchronized between the daemons, but it's already a bit scale out to be a bit faster.
Okay,
at some
nice.
calculations, so
yeah. It's okay. It's all okay. So what I'm talking is about a use case. If you are only focused on some small nodes, or everything is okay for me. Okay, good. Thank you.
And another detail: it's implemented in Go, so it's highly threaded by itself. And if need arises, I think it would be possible. But currently, I cannot imagine where this would be required by current CPUs.
Any more questions? No? Please give a big round of applause.